Okay, so now we're going to compare our experimental and our theoretical probability. So the bar graph shows the results of rolling a number 300 times. So we just kept rolling. We did this 300 times. We rolled a dice. What's the experimental probability of rolling an odd number? So again, I'm going to take my odds, my 48, my 50, and my 49. I'm going to add them all together, and I'm going to put it over 300. So I'm going to have the odd 147 over 300 because I took these three numbers and added them. And of course, I can write it as a fraction, reduce it to 100, so dividing by 3 on both of them, or just dividing 147 divided by 300, you get 0.49. So 49 hundredths, or 49%. Um, so then how does the experimental probability compare with the theoretical probability? Well, if you think of theory on a dice, in example 10.2, you found that the theoretical probability of rolling an odd number is 50% because half of them are odd, half of them are even. The experimental probability, 49%, is close to the theoretical probability. So when we compare it, it's very close. So kind of accurate. Compare the experimental probability in part A to the experimental probability in example 1. As the number of trials increased from 50 to 300, the experimental probability decreased from 58 to 49, so it became closer to the 50%. So what I think they're trying to say is that because we did it 300 times instead of just 50 times, our chance of getting closer to the theory is actually better. Originally, we were 58%. We were 8% away from 50. Then we were 49. We were 1% away from 50. So we went and got closer to our theory. So I think the more that you do the same thing over and over and over, the closer you're going to get to the theory. But again, theory is just theory and probability is as is. It can be different. So good luck in your probability endeavors. So if you think you understand this one, you can try one more on your own on the next page.